Good morning, everyone, and welcome to this, our first webinar, HeatSource Digital Heat Technology. For those of you that don't know me, my name is Fiona McDonald and I'm an Impact Manager at Built Environment Smarter Transformation, also known as BEST and formerly known as Construction Scotland Innovation Centre. Before we get underway, I'd just like to highlight some housekeeping points just to help the webinar run smoothly, as smoothly as possible. First and foremost, the session will be recorded and available to view on the YouTube channel early next week. If you would like to ask questions or leave comment at all, we would genuinely welcome that feedback and response. Please do just click on the questions in the control panel, type your questions and press send. There will be a session on question and answers specifically at the end of today's session. There'll be a couple of poll questions throughout today's event as well. These will appear automatically on your screen and you'll be given around 30 seconds to answer, but I'll prompt you just to let you know when to expect those responses. And as ever, your feedback is extremely valuable to us, and we take all questions and comments on board, even if we don't have time to answer them all, so please don't let that hold you back in terms of the busyness of today's content. And just before we get started with today's guests, I just want to offer a bit of a presentation on BEST and HeatSource and the relevance of today's event. Just hold on, I'll just get my presentation. I'm hopeful there's no issues in seeing today's presentation. As noted, this is really...
Sorry, we can just see your chat box, so it's covering a bit of the presentation. That's it, thank you.
Thanks, Danielle, much appreciated. It takes a whole team of people to organise these webinars in the background. So this is just a very short presentation, just to give you some context in terms of who we are as BEST, how we're working with Scottish Enterprise and the delivery of HeatSource. So in terms of the Innovation Centre and who we are part of a family of innovation centres, 7 in total. Ours is the only innovation centre that's built environment specific, but you'll see that there's some crossover here with the likes of the Data Lab, because data is king for most organisations and sectors. Census, which deliver sensor technology applications, and Industrial Biological Innovation Centre, iBioIC, and this circular economy opportunity that we have. As an Innovation Centre programme, we are all supported by Scottish Government. We are collaboratively funded by Scottish Enterprise, Highlands and Islands Enterprise and Scottish Funding Council. In terms of who we are with our vision and values, we're essentially an international centre of excellence. Our complete mission is zero carbon focused and the transformation of that built environment, so you can understand the relevance of HeatSource and carbon heat. Our vision is to build a better built environment that is delivering on a more sustainable level for economic, social and environmental impact. And we are very much so about enabling the connections and infrastructure to tackle most of our challenges as a sector. And our role is a catalyst to accelerate the built environment's transition towards that zero carbon. How we unlock the value is by sitting centrally, very deliberately between industry, academia and the public sector, and we have all stakeholder representation from those three areas on today's call, which we're very grateful for. That positioning is very deliberate in terms of that connectivity piece and the ecosystem that we're trying to create on the benefit for the benefit of the built environment. We unlock innovation through a number of activities, namely through our connected ecosystem, which we've been establishing now for years in the making. That's us going into year 9 of our delivery model. Also through collaborative projects and programmes, and HeatSource is absolutely core to that activity, being a programme in its own right. And we also have significant investment in Innovations Factory, which also has relevance to today's event in terms of exploration, prototype development and opportunity for skills and testing. And finally, our kind of fourth angle on our activity is very much so the focus on skills and the realisation in the gap and how we can stimulate and support more innovative ways to delivering that skill, but also ensure that the skills resource pool is equipped to deliver when it comes to working in our sector. We deliver our programme through 4 key strands of activity: digital, modern methods of construction, retrofit and sustainability. And just as per my previous slides, all of that activity is underpinned by behaviour and culture change, and again referring to the zero carbon skills and competencies as an absolute area for development and transformation. And I just have a short video just to give you a feel for what you would expect in terms of our centre. This is one of two practices having land fire. This is to be known as our AZ lab, this is our Z lab. Very much so this area for development for skills support, and we cover all things across the 4 pillars within this. We are supporting our industry partners, we unlock funding to access. It also has this huge digital application in addition to the physical manufacturing area of focus. And in terms of HeatSource and what this represents for us, the HeatSource is a collaborative knowledge hub which explores the opportunities in low carbon heat whilst bringing together knowledge, partners, resources in order to help our sector get ready for net zero targets. Our aim for HeatSource is to be the go-to source of knowledge and support, but to facilitate companies in finding out how they can benefit and contribute to Scotland's transition to zero. And HeatSource is where we are hoping to bring all the support ready together for all organisations and individuals across all of the areas of supply chain within this growing sector, including but not limited to manufacturers, installers, training providers, planners, buyers, and that's from the public and private sector in addition to academia. It was a project actually that Best secured through a competitive tender with Scottish Enterprise in January 2022. And it came to the realisation from the enterprise agencies that there wasn't just one single source for low carbon heat sector. So we wanted to pull everyone together and create this ecosystem in its own right for all supply chain parties under this programme. In terms of our objectives, we are very much so in the name of bringing our supply chains together across the country, whilst educating and informing through events like today, in addition to active social media presence and within our website as well. We want to highlight opportunities for collaboration, which is absolutely at the core of everything that Best and our enterprise agencies are trying to deliver, whilst highlighting and creating opportunities for networking in addition to champions for this movement as we move into new territory as a Scottish supply chain and support system. So hopefully that gives you a bit of a flavour from the Best positioning in addition to the HeatSource programme and what that is all about. And you'll see here some of the organisations that are represented as challenges. I also just wanted to offer this QR code in addition to subscribing to the HeatSource newsletter. This is something that we can follow up with in the chat function at the end of today's event, just so that everybody has access to the future programme of events and connectivity. In terms of today's agenda, I'll very shortly be handing over to Rachel McCaw, who is one of the leads on today's event and within the Scottish Enterprise Green Heat team. I will then be handing you over to David Kane at Pragmatic as an organisation, working within this space. Thereafter, it will be a representative from University of Edinburgh, Dean Drobot, and we will finish today's with the final speaker, who is Robin Peters from Snugg. Once our presenters are finished in today's supporting today's event, we will then move on to the Q&A panel session. And just to re-highlight that you can contribute to this as the event goes on, we are collecting questions throughout today's presentations, and I'll collect and highlight as many as we can at the final part of today's session. And I'll just stop presenting there and hand you over to Rachel. Now, just to give you some context in terms of Rachel's background. Rachel is a low carbon transition specialist within Scottish Enterprise and leads on digital technology and green heat. Geothermal energy is in addition to that and is part of the Scottish European Green Energy Centre team to support Scottish companies to access European funding in areas of energy and low carbon for Scottish enterprise. She's delivered innovation workshops to businesses, provides support to companies and undertakes research in key areas, including digital heat technologies. She'll be presenting on the opportunities of digital heat, and there's no one better place to do that than you. Over to you, Rachel. Thank you.
That's great. Thanks so much, Fiona. Let me just get my slide. Okay. So good morning, everyone. Thank you for coming along today, and thanks for the introduction, Fiona. Like Fiona said, I am a low carbon transition specialist at Scottish Enterprise, focusing on digital technology to decarbonise heat, as well as supporting businesses to access European funding. As you might all be aware, Scottish Enterprise is an economic development agency, and within my team, which is the Green Heat team, our aim is to build a robust and internationally competitive supply chain to take advantage of the exponential growth of green heat in Scotland. Just to make you all aware that my slides will be shared after the presentations, as I'm including a lot of kind of useful links to access webinars in the future and applications forms as well for future funding opportunities. So also please keep an eye on the chat box, because I'll throw some links into there as well that will be able to kind of support you going forward. But back to the presentation, Scottish Enterprise commissioned Ramble to assess Scotland's opportunities within digital heat technology. Scotland has set an ambitious target of reducing carbon emissions by 75% by 2030, and decarbonising heat through the application of digital technologies will play a crucial role in achieving this target. Now, back in March, or was it May there, I presented at All Energy on digital technologies. So the slides are kind of similar of what I summarised there, but I've also included additional funding opportunities. So apologies if you've attended All Energy and some things look familiar. So a framework was developed to analyse the present industry state and assess the factors required for future growth. You can see from the table the 5 drivers identified as critical for gaining market leadership. But for the purpose of today's talk, I will focus on technology development and industry capabilities and structure. The report is available to access for free online, and Danielle will just put the link in the chat box for you to read in your own spare time. So what is digital technology in a heating context? Well, it plays an essential role in enabling connection between components, the optimization of systems, additional control over individual components, increased functionality of users, and data collection to gain a better understanding of the building stock as well as user behavior. It consists of electronic tools, systems, and devices that collect, generate, store, process, and share data. And it can be divided into inputs, processing, and outputs, but also further classified into hardware such as your sensors and your microprocessors, as well as software such as the apps and programs that control and operate the hardware. This visualization was pulled out of the report, and it presents how new technologies such as sensors, smart meters, smart valves are integrated in the residential sector. The outdoor sensor is an example of how external input contribution can affect the internal grid. The automatic metering system, as well as the flow and temperature sensors and smart meters and smart thermostats, contribute to the efficiency analysis of the building, as well as allowing setting temperature via customer interface, which will later improve the overall performance of the system. So based on this kind of visualization and example, it shows that digital technologies is greatly contributing to reduce energy consumption and cost through the optimized use of individual system components, effective use of thermal store, and the correct use of variable tariffs. Ensuring thermal comfort through advanced sensor use and data processing, the incorporation of weather data to control the systems, and data monitoring to enable effective fabric interventions. And finally, operating energy systems to optimize energy use in the context of a wider energy network. And this is in context of the altering overall energy demand and user behavior. This visualization focuses on the possible technological applications in existing and new commercial and office buildings which tend to be a lot more complex and customized. Digital inputs are where external data is integrated into the system through sensors, external modules, and smart metering. Digital processing, like digital twins and building energy management systems, integrate present, historic, and forecast data to optimize the energy production and maximize the lifespan of the system. Digital outputs through customer interfaces, such as apps, dashboards, and displays, allow remote control as well as data sharing. So the objective in this setting is similar to the residential sector, is to reduce overall energy consumption and costs through optimized use of individual components and the thermal store, as well as correct use of variable tariffs. System optimization and smart learning through artificial intelligence, digital twins, to learn about possible improvements and the detection of faults in the system, as well as flexibility and grid integration. So here is a progression pathway with our ambition to move towards the right. Scotland is currently focusing on data gathering with the aim to allow heating optimization and future power grid integration. Currently, data is gathered from technologies such as smart thermostats, humidity sensors, and smart meters. But in the near future, the focus will include interconnectivity to external systems, including weather data and variable cost tariffs, which enables more advanced operation to optimize the cost of heating and help balance the national grid. And in the end, digital technology aims to connect individual elements of a heating system together for whole system integration, where consumers will be central to this system, becoming active participants in the energy market, buying and selling the energy they can generate in their homes. So on to the next part, which is industry capabilities and structure. So during the research, 47 stakeholders were identified as relevant in the heat tech industry, but this is constantly growing. 37 of which were companies representing different roles within the industry. The digital heat tech industry in Scotland, we've identified as a growing but young sector, predominantly dominated by SMEs. It was also identified that remote diagnostics was missing in the market, and this is essential for predictive maintenance of our systems. And the application of advanced technologies such as big data, artificial intelligence, and machine learning for low carbon heat is also at very early stage, and again, mainly developed by SMEs. The research and development sector for digital tech is growing, with many universities focusing on low carbon tech, as you can see from the examples below. We also had Dean Drobot from the University of Edinburgh talking to us later today about HeatSource and digital twinning, so we'll hear from him later. There is a need to develop a dedicated research and development centre to accelerate the university's contribution to the sector and combine their capabilities through collaboration between existing low carbon heat and the digital tech centres. Now, we'll all be aware, and like Fiona mentioned earlier, Scotland has strong innovation centres all across Scotland and within all needed areas of expertise for digitalising heat. So we do have BEST, Census that focuses on sensing and Internet of Things, Data Lab, big focus on data and artificial intelligence, as well as Innovate UK. But the crucial challenge is the missing link between low carbon energy and digital technology, as there's no organisation that brings together the stakeholders from these two groups, especially that aimed at increased collaboration between private organisations. And to be able to compete internationally, the growth opportunities lie in advanced technologies, support for Scottish companies, and increased interoperability. The biggest potential for growth, which is starred there on the bottom right, is focused on software and techniques enhancing the connectivity between different systems that can further contribute to the whole grid integration. So in conclusion for this section, the development of the Scottish industry for low carbon heat relies on the collaboration and collective action between key actors amongst policymakers, network and industry organisations, universities and companies. Now, if you are a company within the digital heat space interested in this area and funding available, I'll discuss this in the next section. And like I said earlier, I'll be putting a few links in the chat box to access some webinars that are coming up to explain some of the funding opportunities further. So first up is the Green Heat Innovation Support Programme. This is in partnership with the Scottish Government, Highlands and Islands and South of Scotland enterprise agencies. It's known as GHISP, which supports innovation and capital investment that will accelerate the rollout and adoption of green heating solutions and associated products. Areas of focus include your heat network component manufacturers, heating product and component manufacturers, including all types of heat pumps, energy efficiency products, but also your enabling products and components such as smart controls and smart meters. £17.6 million is available to companies all across Scotland until March 2026 and can be accessed in a variety of ways, including grant funding, feasibility studies, can-do innovation challenges and European funding. It's open to companies of any size based in Scotland, or at least a company looking to invest in Scotland and plans to use this existing technology in an innovative way. Now, just to detail a little bit more on the funding available, the research and development and capital funding is always on. The percentage level of grant support will depend on the project activity, the size of your company and the location. Once an amount has been allocated, you'll be required to fund the rest of the project independently. Projects seeking support through GHISP should complete an expression of interest form on the Scottish Enterprise website. And Danielle will put that link in the chat box. On my next slide, I'll talk about the recently announced feasibility support and European funding. So 100% feasibility funding, that's 100%, is in place to develop products and processes that will accelerate the uptake of green heat solutions all across Scotland. It's aimed at different building types, including domestic and commercial buildings, new or retrofit. The grant support is for 100% of the eligible project costs, and this will allow companies to undertake detailed analysis, design and assessment of the technical and commercial feasibility of their proposed solution over a period of 3 to 4 months. The key challenge areas include heat pumps, green heat systems, geothermal, data and control management, energy efficiency, and thermal store. The funding will only cover the feasibility stage of your project. You must intend to commercialise your solution to the challenge. This commercialisation must support the development of Scotland's transition to a green economy. Grants between £30,000 and £50,000 are available for companies in Scotland, and the size of the grant is based on the actual cost to the company. Each application is assessed according to the requirements provided in the challenge details. Now, the project submission deadline is the 22nd of December. To be eligible as a business, you must be registered or trading in Scotland or looking to set up trading and be committed to fair work practices. The eligible costs for the feasibility projects include employee wages, contractors, consultants, supplies and materials, and travel costs. The application process is simple. Please visit the Scottish Enterprise website. Danielle can put that in the link of the chat box for you. And using the link above, or you can also use the link above, you can complete the application form and you'll be asked to explain how your proposed solution will address the challenges stated in the brief, technical innovations, describe the commercial opportunities as well as project costs. Once you've completed the application form, you can email inquiries@scotent.co.uk. And in terms of the timeline, so this is some important dates for you. The call closes 7th of July. We did announce or launch this feasibility call during All Energy, which was on the 9th of May. But like I said, the call closes the 7th of July. The project is to end and close by the 22nd December. To find out more, there is an opportunity to attend a webinar which will take place on the 15th of June, where our innovation specialists will attend and be able to answer some detailed questions for you. Like I said, I'll share the presentation at the end so you can click on the registration link, but also Danielle can share the link in the chat box. And next up is European funding opportunities. So Scottish European Green Energy Centre, also known as CGEC, is a small but mighty team sitting within the Green Heat team at Scottish Enterprise. It's a team that I'm actively part of alongside my colleague Richard, who will be on the Q&A panel from 12 p.m. later today. Our aim is to help attract European funding to Scotland in the critical growth areas of energy and low carbon by supporting businesses and key stakeholders. A key focus of CGEC is Horizon Europe, which offers a significant opportunity for Scottish businesses to develop world-class innovative technologies in collaboration with partners across Europe. I won't go into much detail about Horizon Europe during today's session just because of time, but please get in touch with myself where I can arrange a one-to-one conversation with you at a later date. But now I'm going to talk about the CETP partnership as well as the Smart Energy Systems funding opportunities. But first, just to give you a little highlight on how the team CGEC can support you. The idea of applying for European funding can be a daunting task for most businesses, but there are a lot of businesses or lots of benefits not to be missed, including huge funding pots and collaboration with other European countries. The CGEC team is here to help, and we can support your business to navigate European funding landscape, identify partners, strengthen funding applications, increase your application success rate, and encourage that international collaboration. We continue to engage with institutions, networks, and technology platforms to identify these opportunities across the industry, including Scotland's Europa team, where I had the privilege of meeting them in person in Brussels earlier this year. We've also worked closely with Innovate UK, Enterprise Europe Network, as well as the Energy Technology Partnership. So the next funding opportunity, which is a very exciting one to collaborate with Europe, is the Clean Energy Transition Partnership. It's in collaboration between the European Commission and economic development and research funding agencies all across Europe. Its main purpose is to provide funding to transnational collaborative research, development and innovation projects, tackling the key challenges for transformation of the energy sector and developing new technologies and products for European companies to respond to the global market opportunities. It was launched last year, and we're launching the second lot of funding calls at the start of June. Now, the whole programme plans to run 6 calls for projects from 2022 to 2027. The total budget for the first 2 calls is over 200 million euros, and each partner in a collaborative project will receive funding from its national or regional agency. With 5 million available for Scottish businesses and partnering universities and research organisations, this is an opportunity for companies to access funding for research and innovation projects that support the green transition and collaborate with partners from over 30 different countries. Funding is up to 50% of eligible costs for SMEs and 40% for larger companies. Projects must involve international collaboration. Each project proposal must include at least 3 independent legal entities from 3 different countries. And you'll see there a list of 10 different funding modules available. And within this, digital technology will sit in nicely. So if you'd like to find out more, you can get in touch with the CGEC team. I've included the email there. but also just to make you aware that there'll be a launch webinar on the 7th of June, but that's for the wider European networks that you're able to attend. If you visit the CETP website, you can register. But Scottish Enterprise is hosting a webinar on the 15th of June at 10 AM for Scottish businesses, and we can sit down with you and your team to explain the application process and benefits. Danielle will put the registration link in the chat box, but also I'll share the slides afterwards. Now, EnerDigit is a joint call on digital transformation for green energy transition. The aim is to support transnational research and innovation activities, unleashing the potential of digital transformation for sustainable energy society. The joint call will be launched on the 14th of June with an event on the 13th of June. I'll share the link for this at the end of the webinar. But this project's a big focus on digital technology for green energy, and it's aimed to address key challenges and opportunities, including energy and ICT infrastructure, energy marketplaces, businesses, models and communication, and society and sustainability. Funding is available in Scotland, Germany, Austria, Czech Republic, Romania, Turkey and Sweden. Projects must involve partners from at least 2 countries, and the Scottish Enterprise funding pot is 1 million. Like I said, the launch event is the 13th of June. The call opens on the 14th of June. Scottish Enterprise, similar to the CETP call, we're hosting an online information event on the 20th of June, and the call closes the 12th of September. So really tight turnaround. So we'll be promoting this call at a later date as well. So keep following our kind of social media platforms. And who can apply? Both for the CETP and EnerDigit?
1 minute left.
Okay, I'm nearly done. So we've got small, medium and large companies registered, operating and carrying out research and development in Scotland. You must be involved in research and development activity. And for the grant rates, SMEs up to 50% and large companies up to 40%. And you'll see here in the boxes the registration links that are available for the upcoming events. And finally, we've got the Net Zero Living Digital Accelerator. The call closes on the 7th of June and aimed at ambitious early stage digital focused businesses developing and delivering net zero. We have a FIS team, Funding Information Support Services team within Scottish Enterprise that can tell you more about this funding available and talk you through the application process. So please do keep in touch with us. We have a Green Heat newsletter and also a European funding newsletter. Appear on the Scottish Industry Directory website. We're really trying to build up the digital side of that. So if you are a digital company interested in heat, please sign up to this directory to get your name out there. And like Fiona said, we've also got the HeatSource newsletter to share that information that we have. Okay, that's me. Thanks for listening.
Excellent, thank you very much, Rachel. There's some really interesting content there and activity going on to both instigate and support the sectors that we're here to engage with today, and fantastic on the funding opportunities too. As Rachel noted, there's links being shared in the chat, but please, in addition to that, do not hesitate to reach out to any of today's panellists after today's event to follow up accordingly. We're just going to move on to a quick poll now, so you should see on your screen a question appear. If I could just ask you to take a vote. What is the biggest barrier to homeowners installing low carbon solutions within their homes? Is it cost, lack of awareness of solutions, perceived disruption, or there's just no interest? And I'd be really interested in your views on this one. Thank you very much. Just give you a moment. Excellent, interesting. So cost, now that's really indicative of where the market is, so thank you. for sharing your experience in that capacity. Much appreciated. We're just going to move on to your second speaker now, who is David Kane from an organisation called Pragmatic Energy. So Dr. David Kane is a chartered engineer with 20 years experience in energy systems, research and development, project modelling, design and delivery, and energy auditing. After years of developing heat pumps, CHP and energy storage systems, his focus is now digital systems to enable smart grids, low carbon heating systems. So with Pragmatic Energy, David and his colleagues are explaining and closing the performance gap between design and operation for residential heat pumps, whilst unlocking time of use and renewable integration opportunities. David, can I just ask you to share your screen, and over to you. Thank you.
Great, thank you very much. Hopefully everybody can see my screen. Thanks for that, and thanks for the invite to speak today. It was a great presentation from Rachel, and it's always really hard to follow on after a good presentation, especially when someone's trying to offer you lots of money. So today we wanted to focus a little bit on the different types of digital heat platforms that can support rollout of heat pumps, where we think there are some gaps, and where we can see different kind of players trying to plug it, and try where possible not to be a shameless sales pitch. I should say that Pragmatic Energy originated about 3 or 4 years ago between two product development consultancies who are developing smart controls, thermal stores, heat pumps, etc. on their own and in the context of wider energy systems with solar, batteries, EV chargers, etc. And after many years of pushing every possible technology into a project, so lots of additional sensors, lots of storage technologies, etc., kind of linking in quite heavily with Rachel's slides, we took a step back and said, well, that's great. That's almost heat pump 2.0 that we might get to in 5 or 10 years. But the heat pumps of today have already got a lot of intelligence in them. They've got a lot of controls in them. They've got a lot of hardware with them. So let's try and make as low cost a heat pump as possible work as well as it possibly can, because only once that rolls out to the market will people have the trust to invest even more money up front to get longer term savings. So everything that you see today is from a group of people who would love to throw the kitchen sink at a project, but instead of trying to take a step back. If I can make this work, sorry. So what we're going to quickly cover is why do we think we might need digital tools, and what kind of tools do we think would really help the heat pump market. Talk a little bit about the performance gap, so the difference between how we design it and how it operates in reality and how you might close it. And at the end, just offer a few examples from Pragmatic's product suite to see the different tools there are and how we think they might evolve over time. So this is a kind of shameless pull from Bayes' targets, but when you look at current heat pump market, which is probably 30 to 40,000 units per year in the UK, probably growing already in the last 6 months. But if we're looking at doing hundreds of thousands to millions of heat pumps per year, then we need to solve a lot of the challenges pretty quick. So yeah, we're all here because we believe heat pumps can be a pretty effective solution to decarbonise heat, but the heat pump experience is going to be so different depending on the number of people in a property or the type of property, and whether it's a new build or a retrofitted heat pump into an older system. It's probably likely to be a lot of kind of constraints to uptake of the perfect heat pump solution from every site. That could be space to put a heat store, for instance. It could be network capacity constraints limiting the capacity heat pump you can use. So there's a lot of kind of challenges there, but there's a lot of opportunity being dangled in front of everybody's nose. So for instance, let's derive a lot of money from heat pump through time of use flexibility, chasing time of use tariffs. Well, that's a great idea, but it's much more complex to do than in, say, an electric battery. So there's quite a lot of challenges to deploying heat pumps. There's quite a lot of opportunities for heat pumps, but the thing we can't do is suffer a lot of underperformance in the market, because all that happens is it ends up in the 6 o'clock news and everybody thinks, I just want a gas boiler because these heat pumps are far too risky. So what we think is, in order, if you want to deploy this amount of heat pumps as quickly as you want to deploy them, as quickly as we need to deploy them, we want to deploy it cost effectively, then we need digital tools. Digital tools allow us to do two things. It allows us to automate a lot of the assessment or intervention we might do, and it allows us to drive standardisation. And standardisation will make everybody's life easier. As there's some kind of standardisation and approach, it'll make it easier to train people, make it easier to target the right kind of product sets for projects, and it'll make it easier to kind of produce standards that we all have to comply with, so produce the regulation, etc. With that in mind, we've just tried to kind of break out 4 of the most kind of standard areas for digital heat. I'm aware that we're followed by Dean from University of Edinburgh, where they've got some examples of how they've developed this either from an academic basis or developed these kind of tools from a kind of in-house facilities team. And then the team from Snugg are probably going to talk a lot about how you might specify and design to prioritise interventions in a building. What we've seen from looking across the kind of product life cycle is the bit that tends to get under captured thus far is the middle: installation, commissioning and operation. Rachel talked about it as remote diagnostics. I think remote diagnostics is a pretty broad term, but if you talk about it from the point of view of what's missing, then what we're kind of missing is some kind of digital tools there that take advantage of all the data that can flow from a heat pump or a heat store and make sure the installation's done properly. So providing quality control and quality assurance, remotely verifying this, making sure that heat pump has been physically installed okay, commissioned okay, but perhaps most importantly, all the kind of digital settings within a heat pump have been configured appropriately for that installation for the site it's installed in. As you can imagine, heat pumps are shipped from the factory with a pretty standard set of generic configurations on them. And there's a 250-page installer guide that if an installer wades through it, they might figure out how to set every single setting in this heat pump to make it as effective as possible for that site. No one ever does it. No one ever does it for 2 reasons. Number one, it's 250 pages. It's pretty hard, takes pretty long, and you really need to be a controls engineer to fully understand it. And then number 2, the last thing you want to do is twiddle with all the default settings, have a customer that doesn't get a warm shower in the morning or is cold, who then calls you back. You start off on the wrong foot, but you end up spending a lot of money trying to snag issues that were perhaps caused by the fact that you tried to make the heat pump work as effectively as you can. But then as we go into kind of full-time operation, it's clearly not just set a heat pump up and leave it alone. Occupants change. You know, people come home from, say, uni from summer, or people move in and out of properties. People have kids, and the kind of use of your house can change quite a lot. So as your use of the house changes quite a lot, you may need to re-optimize a heat pump. But also a heat pump gets installed on day 1, but it takes a full heating cycle to really understand how well that heat pump is set up and how well people understand how to control the heat pump, how to use all the tools at their disposal, from smartphone apps to smart thermostats to the simple little box on the wall with the heat pump. So we see that's the real gap. There's huge amounts of people in the market who can provide specification and design tools. The heat pump vendors do it, and many other people do as well. And the heat pump vendors thus far have been fairly good at providing digital tools to allow you to remotely diagnose and service a heat pump. The biggest issue is that it's not standardized. Everybody's doing it in a slightly different way, and quite often they make you pay for it, or they only allow access to trained installers, etc. But the key message out of this slide is there's lots of tools required. Perhaps the bit in the middle is the problem. And where we really see a performance gap happening is the difference between what you've designed up front, what you've got your SAP score based on, or your EPC rating, and the operation of the heat pump. So if we drill in that a little bit, what do we mean by a performance gap? Well, at design there was an assumption about the weather. It's quite often maybe a little bit warmer than you are in reality. So warmer weather will mean you've got lower demand anyway. And because heat pumps prefer it to be slightly warmer outside, the heat pump in itself will have a higher COP, or coefficient of performance. So there'll be less demand to meet, and it'll need less energy to meet that smaller bit of demand. We also can assume that people know what they're doing with heating controls. They know how to use room thermostats and hot water tank thermostats. They know how to use time clocks. It's not the case. We also assume that an installer has spent 6 hours adjusting all the digital settings on a heat pump and testing a heat pump after they've installed it to make sure everything is not only working properly, but it's tuned as much as it can be. And those kind of things, and that isn't the case. In reality, it's probably colder outside. People are probably have left their set point set at 23, 24 degrees one day, or left the cylinder on a boost temperature. Time clocks tend to be underused. There tends to be issues all the way from a valve not being fully open, so the heat pump doesn't get the flow rate it needs and is a bit less effective. And quite often, all of these integral controls that have been designed for the last 20 or 30 years to make heat pumps as efficient as possible have all been left in the most conservative setting, which basically means they're not really doing much. They're not doing much to increase the performance of the heat pump or reduce the demand in the house. So we think there's a couple of different ways that you can try and close this performance gap. Some of them are easy, some of them are hard. It's obviously weather. Unfortunately, we can't do much about the weather. He says on the warmest day of the year. But what we can do is if we find that the kind of regional weather used for designing one stage of a project really didn't keep up with the realities of how cold it can get, or maybe overheating issues or whatever else, then we could update some of the design assumptions. So that can flow into other products in the marketplace to say, I'm a local authority or a housing association operating in this part of the country, and I tend to maybe oversize a little bit so that when it is colder than the kind of average temperatures I'm given, my heat pump doesn't perform overly poorly. It could be that the performance gap has got nothing to do with the heat pump itself or the weather, it's the building. Maybe the building hasn't been as performant as we think. Well, maybe in an extreme case, we might retarget some fabric improvements, or just look at the next stage of a project or the next project you do and try and update the building designs and say, that didn't work very well. But if you've got all the data that's flowing out of a heat pump, you can actually understand what the demand was. So not what the electrical use of the heat pump was, or how warm someone left the house, but you can focus in on what was the heat loss of that building, how performant was the building itself, was it built the right way, was it designed the right way. Occupants are a much trickier thing, but what we find is a huge amount of the performance gap is down to people not knowing that they've got a time clock or how to use the time clock, not really understanding that if they set their room temperature to 20 or 21 degrees instead of 23, they can save a huge amount of money. Not only does it reduce their demand, but can make the heat pump work much more efficiently. Heat pumps love it to be warm outside and provide a relatively coolish temperature inside. That gives the heat pumps the kind of optimal operating range. The other thing we find is people just don't understand boost heating controls. They've used it one day because everybody's came back from a walk and they're cold and they're wet and they're all trying to go in the shower and the hot water's running out, so we hit the boost button. But quite often that just becomes a habit or gets left on. So these kind of things, if you can educate the user on these are the tools at your disposal, this is how to use it. But by the way, here's the penalty you're paying right now. This is costing you an extra 50 quid a month, say, to try and make it kind of here and now for people can help. But the other thing we can do is update design assumptions, because it might be there was an assumption that that 4-bedroom house would only ever have 4 people in it, and therefore a small water tank is the way to go. In reality, that 4-bedroom house quite often might have 6 or 7 people in it, and having a slightly bigger hot water tank would mean that a heat pump can spend longer operating in its sweet spot, charging it up, instead of always having to rush trying to heat a hot water tank quickly, or people using boost elements that are inefficient and stuff like that. And then the final thing, and this is what we bang on about quite a lot, is there's been decades of innovation in heat pump controls. Heat pump controls have came out of decades of commercial building energy management systems. They've come out of decades of combined heat and power systems. They've come out of decades of trying to make boilers incrementally better. There's a huge number of parameters in there that can make your heat pump really efficient. You just need to use them. You don't need a lot. You don't need 600 or 700 quid of external controls when the heat pump's actually got a lot of that logic in there. You don't need the cloud to take over and control your heat pump minute by minute. But what you do need to do is maybe use the cloud or other approaches to try and understand what is the best set of parameters for the building you've got, the heat pump you've got, the occupants you've got, so that heat pump can be as effective and efficient as possible. And all the kind of remote diagnostics and service tools can help address any of the physical problems there's been, can assess, is there a physical problem there? Is there likely to be a physical problem there? It can prioritise across a fleet of heat pumps where you do your follow-up visits, where you try and find problems and correct them. So time for a bit of a shameless plug. So as I say, we came at this from a background of developing new heat pumps, developing combined heat and power systems, developing thermal stores, developing control systems. And when we looked in at the heat pump space, we realised, look, the only way to do this is to try and develop something that's kind of technology agnostic. So we don't care if it's an air source heat pump or a ground source heat pump or a standalone heat store, of which there are some manufacturers in Scotland of that tech, whether it's a combined heat and power system or a smart storage heater. We shouldn't really care which supplier it is. We should look to try and standardise an approach that can be used across a wide range of different suppliers. But quite importantly, make sure we can integrate with other digital tools. At the end of the day, people probably use a huge number of tools to manage their fleets of assets or manage their quality processes, and indeed to manage the kind of design of the systems. We also, though, need to make sure we can evolve with the market needs. So today, people are worrying about heat pumps that they have just deployed, and they want to make them better. They want to support them throughout the life, but eventually they're going to want to feed these learnings back in up front to how they survey and how they sell and how they design a heat pump. So with that in mind, we've spent most of our time focusing on how we report and then enhance heat pumps to try and close the performance gap. So we're not focusing on the really sexy stuff like time of use tariffs and flexing a heat pump or flexing a heat store. We've done it, we can do it, but we find that actually there's a huge amount of benefit in just making heat pumps that are installed today or about to be installed tomorrow, make them work as efficiently as they can be, and try and reduce all this extra demand because people don't know how to use a time clock or whatever else, and try and support fleet owners and try and support occupants and residents to do that. And we think we can kind of do this because we've came from the background of being building physicists, we've been controls engineers, we've been system designers, and try and say, right, well, there's a lot under there, there's a lot of assumptions under there that we can pick apart, but there's also a huge amount of existing kind of controls and hardware that can be built upon. So we don't need to go and put lots of extra hardware in the house. We can use all the capabilities that are in there on heat pumps already. And just very quickly before we wind up, so with that in mind, we've seen quite a lot of interest in this idea of collecting data. You'll probably notice quite a lot of commonality with Rachel's slides, but collecting a lot of information from the heat pump itself, from heat meters, electric meters, from weather data from the cloud, tariff data, etc., providing ways for the resident to enter tariff data in a smartphone app, or say a support officer in social housing to enter kind of tariff data, etc. Monitoring the heat pump in real time, but the heat pump doesn't just tell you what it's doing. It gives you a huge amount of information about what the building's doing, with all the kind of temperatures and the flow rates and how customers are interacting. You can tell quite a lot about the building itself. And we find that kind of the word alerting gets used quite a lot, but alerting can mean different things. Alerting can mean something when you're in the middle of snagging and handover. You're trying to find heat pumps that have just been left completely in the wrong mode of operation and they're costing somebody 20 quid a day to run when it should be £1 a day. But it can also be in a kind of rolling ongoing basis of prioritising which heat pumps might need to be intervened with, or which occupants might need the best advice. And that might not just be because of cost of carbon, but might also be because of other drivers like fuel poverty. And if we can report that out to people in a way that's pretty accessible, that can allow people to take action. That's the most important bit. So we find our kind of first tier is really important. Underneath that, however, we've banged on quite a lot about.
Eva, just 1 minute warning, please. Thank you.
Yeah, no worries, great. So I'll wind this up. But yeah, our biggest message is there's a huge amount of intelligence in heat pumps already. Adjust the settings and use it. Once you've done that, though, there's a lot of opportunity for the future. optimising against time of use tariffs, against kind of on-site seat PV that you've got, and feeding all of that intelligence into some integrated modelling and specification for future. That could be on something like the Pragmatic platform, or it could be with all the other platforms that you already use. And very quickly, in my 60 seconds that's left, just a few screen grabs from our platform where we look at different types of fleet level views to help people understand the performance of systems day by day, for instance, and identify where a heat pump was running in its sweet spot, where it was a bit stressed, where perhaps people left the immersion heater running all the time and you really need to intervene. And we think it's important not only to look at the fleet level, but to be able to drill into individual sites. And this example here is showing some days of the year where perhaps the heat pump was undersized because it had to use backup electrical heating to get it there, which was quite inefficient, and that might play back into either reducing the demand in the house by giving people advice, or changing the kind of design criteria for future. So thank you all for your patience. Any questions, please follow up with my colleague or I. Thanks a lot, everyone.
Excellent. Thank you so much, David. I'm sure you've hit a few notes, many notes in terms of challenges that some of our audience members are experiencing firsthand. So thank you for sharing. Just moving on to our third speaker for today is Dean Drobot, who is Head of Energy and Utilities at the University of Edinburgh. Dean will give a brief overview of the university experience utilising emerging digital tools with a focus on utilities, master planning and low carbon heat strategy. The presentation will explore data visualisation tools, geospatial mapping, occupancy monitoring and assessment, utility network modelling, building performance analytics and the development of a range of digital twins to support estate operation. Over to you, David. Thank you.
Hi everybody, my name is Dean Drobot from the University of Edinburgh, and as was stated, I'm going to give a really flying overview of some of the digital technologies that the University of Edinburgh are exploring to help us optimize our campus performance. And what I'm going to focus on is some of our areas of focus, some of the challenges that we've come across, and lessons learned. So first, for a bit of context, the University of Edinburgh is one of the largest higher education estates in the UK. We cover 550 properties of various scales, over a million square meters. That cuts across 7 campuses, and on 5 of those we operate our own district heat, power and cooling networks. And 2 of our sites are embedded with partners, including the NHS. So we have quite an extensive estate, but it also gives a particular context for how we are looking at heat and next generation of energy technologies. Our vision at the university is to be an international exemplar for smart urban energy systems, and that includes providing resilient, flexible and sustainable infrastructure that's going to be capable of meeting our strategic and operational needs for the next century. Being the sort of institution that we are, we want to leverage our research and innovation capacity internally to enable technology demonstration, which supports international research priorities. And of course, at the end of that, we want to be able to deliver on our net zero emissions targets from heat and power by 2040. And we're trying to deliver those in line with a credible science-based target, which gives us quite aggressive annual carbon budgets that we need to meet. So I'm going to focus today on some of the detailed data collection and visualization tools that we've been looking at. But I think if we take that wide step back on what this means in terms of a whole system, and just picking up on some of the points that Rachel and David have touched on, when we talk about a smart campus at the university, that covers quite a wide range of things when we start to look at our forward vision. And so this diagram that we have on the screen starts to touch on all aspects of that network. So on the left-hand side here, we have how some of our energy centers and networks are going to start to integrate with the wider regional energy networks and what that might look like, and then some of the things that were referenced from David and Rachel to date, how we integrate with time of use tariffs, how we operate existing fossil fuel assets on our site in a credible way, where we have embedded generation on our site, how we introduce thermal storage. All of that is part of our utilities master planning piece. Way over on the right-hand side, we've got what's happening in our buildings, which is really going to be the focus of a lot of what I talk about today. which is how we can start to do analytics on how our buildings are operating. And I think as we start to look towards that low carbon heat future, all of this needs to be much more data informed, much more dynamic than in the past. And we have quite a few challenges to get through to make that a slick, a functioning system, I think, over the next decade or so. So within the University of Edinburgh, there's quite a wide range of data mapping and visualizations that's taking place, not just with, with the team that I sit on within our States department, but across our academic colleagues and some of our other corporate services departments. There's lots happening in the realm of sustainable travel mapping, monitoring biodiversity on site, doing air quality monitoring, green infrastructure mapping, looking at space utilization, study space booking, security mapping. But where I'm going to focus on, which is more the sweet spot where I sit, is on the energy and utilities data capture, how that starts to integrate with things like occupancy monitoring in our buildings and our building management systems, and how that again starts to integrate with some of our 3D space mapping. Areas of focus for us over the past few years have been in a few different areas, but I would say one of them is around basic data management. So as we start to look at some of these new digital technologies, you really start to become focused on the quality of your data and data cleansing, making sure data sets are clean, whole, and accessible. Who are the data stewards who can maintain and manage those? Is from a governance viewpoint, been quite an important journey for us over the past couple of years. A particular area for focus for our team in particular has been improving our geospatial mapping, particularly of our energy networks, because the University of Edinburgh is embedded within quite a large, across several local authorities. Having that geospatial plan starts to become quite important. With almost everyone that we've been working with, we've got many dashboards. I won't say too much about dashboards. We have a lot of them. They're all colorful. Only a handful of them, I think, are insightful and useful. And we've got that frame looking forward is how can we take lots of interesting dashboards and turn them into a small number of quite useful ones as we start to bring some of these different systems together. At the university, we've been looking at creating digital models. And this is really an exploration stage for us. So we have some experience of doing quite a lot of modeling, but starting to get our head around how we might need to do that differently, or how these things will evolve, particularly when we start to bring in these data layers. So we've been trying to expand the complexity and the usefulness of our building physics models that we developed. We've done a pilot project across 10 buildings of different typologies to try to build fully functioning dynamic simulation models that allow us to integrate data with them and do better scenario planning. We've started to play around with improved hydraulic models. As I say, we operate 5 district heat cooling power networks, and trying to look at how we might be able to optimize our heat networks is quite an important objective for us. So creating hydraulic models has been an important exercise, and I'll touch on that in a little bit more detail. And improving on just basic energy modeling of our sites. So using energy modeling packages to help optimize the operation of our energy company, which runs our heat, power, and cooling networks. And probably the area where we focused most of our time has been on building performance analytics. We've completed a pilot initially around 6 buildings, expanded up to 25, where we start to explore ways that we can bring together data sets from energy, from occupancy, and from our building management systems into one analytical space, and to allow us to really improve that continuous commissioning program, continuous commissioning of our existing buildings on the site. So I'll start with occupancy. We've been working quite closely with our information services group, who maintain a very comprehensive occupancy monitoring program. They can provide for us within the estates department some very interesting data around the movement of our students and staff around our campuses, which is the diagram on the right-hand side there. How people are moving between our buildings, the diagram on the left-hand side, at different points of the day, and then what's happening inside our buildings at a much more granular level, whether that's in and out of a building, or between floors, or even at a room level within our buildings. So that ability to start to gather user occupancy utilization information around our estate has really come to the fore over the past year. Space planning and utilization, we've got about 90% of our estate mapped within our space planning models. These models currently detail basic building details like age, typology, what's the listed status, the building size, and they start to layer in room details, room size, occupiers, function. And again, colleagues within the estates department who lead that are really starting to build up those digital data sets. And what we're working on at the moment is integrating that with other data sets such as energy use, space utilization, cost metrics, and trying to then pull together useful dashboards and planning and reporting tools that can give you insights into what that data is telling you. In the area that I've been looking at a little bit more closely, we've been trying to pull a lot of our utilities infrastructure into geospatial tools. We've used our Holyrood campus in the Edinburgh city centre as a pilot project, which has allowed us to take our assets and embed them in a new geospatial model, which we can then coordinate with our building GIS models, and it helps us really lay out our assets in parallel with other asset databases. What we found is the geospatial mapping has been really useful in visualizing our assets and networks, but it has also brought to the fore the challenge around poor record information. And looking ahead, I can foresee challenges in how we start to approach information management, and that's going to require some significant thought and resource to drive forward new processes for information management and data integration. On the back of being able to pull all of our utilities networks into a geospatial model, we've also taken the opportunity to start to build up hydraulic models, working with a company called HeatSource. To date, we've developed 3 hydraulic model pilots. The first of those focused on the evaluation of one of our poorly performing campus heat networks. It was a network which was characterized by unstable heating flow temperatures out onto the network and very poor return temperatures coming back from the buildings onto the network. And we found pretty quickly that one of the barriers for us was a lack of accurate as installed building level information on our heating distribution assets. Even with site surveys, we found that lack of accessibility to installed heating distribution components was a challenge. So I think looking forward, building level hydraulic modeling is going to be limited for us, although quite valuable, I think, on some of our more complex buildings when we're looking at a new build situation. Notwithstanding, when we took a step back from that building level of detail, the hydraulic model led to some very useful insights on the optimization of our primary networks and our energy centers. And I won't dwell on that in too much detail, except to make one point, which is what was very useful for us was that ability to create a hydraulic model of something like a heat network, to be able to do some scenario modeling on it and look at where we might be having some problems on that network, but then to also take information from our metering and our building management systems and overlay what was happening in reality with what that digital model was telling us was happening, to give us confidence that what the model was predicting was being matched in reality about what we were monitoring on site. I can come back to that if there's any questions on that, but I won't dwell on too much in the detail at this stage. One of the larger projects that we've undertaken over the past few years in this space was looking at how we can improve building performance analytics. And this is quite important to us because when we look at an estate like the University of Edinburgh, as I say, 550 properties of various sizes and scales, it's not the new build arena where we've got our challenges. It's how we transition all of those existing buildings into this new low carbon heat world. The aim of this project was to pilot data and analytics technologies aimed at identifying meaningful opportunities to close that performance gap, which David had spoken about in his presentation, which is very prevalent. Not just it's prevalent in new build, but it's for us on the existing estate. There's quite a gap between, I think, what is achievable on some of our existing buildings in terms of what good looks like and what we're achieving in reality. So we try to achieve this by bringing together energy data sets, utilities data sets, building management system data sets, and occupancy data sets to help us evaluate the performance of our buildings and the HVAC systems within those buildings. And this particular project was a collaboration between ourselves, the University of Edinburgh, Schneider Electric, who's one of our incumbent controls providers, and Integrated Environmental Solutions, a Scottish company that I think is most well known for their building simulation models, but also quite a lot of other digital tools that they've developed in the analytics space. So the project allowed us for the first time to look closely at building occupancy patterns, average occupancy, peak occupancy, weekday versus weekend, day versus night, and to explore meaningful ways to visualize that. We can then combine that with energy data. Energy flow analytics, I tend to use this slide to try to explain to people the value of simple data tagging. So being clever with how we digitally label our utility meters, a very simple asset with meter location, end use, parent, child, relationships between meters. And if you do that correctly, you can now start to create some very insightful visualizations. So typically what you would be able to read in this space is what's on the left-hand side of this diagram, which is how much energy is coming into a space. But by tagging that data correctly, you can then start to visualize end use information much more accurately, which is far more insightful when you're trying to analyze where your issues are and when outliers start to occur within buildings. When you bring those together, you can obviously look at where energy demands and occupancy patterns aren't correlating. And with playing around with different visualization tools, you can start to see outliers from normal data fairly quickly. So starting with that understanding of where we may be having performance issues, where energy demands are high, occupancy is low, to take it to that next step, we need to start then looking at what's happening to our heating, ventilation, and air conditioning systems within those buildings, why they're not responding to occupancy or to conditions in the way you would maybe expect. And one of the first tools that we piloted was some proprietary software from Schneider Electric, which allowed us to do some analytics across our HVAC systems. So building performance analytics identified a consistent set of anomalies across our HVAC systems, and that allowed us to optimize performance, improve environmental conditions, and achieve energy savings. And in summary, across our 6 pilot buildings, we quite quickly identified about £100,000 per annum in actionable energy savings, which corresponded within that building group around 3% of the annual heat and power costs for that portfolio of buildings. We were undertaking this during COVID times, so we had certain operating regimes in place which limited what we were able to do. So I think 3 to 5% is a reasonable range of savings, which doesn't sound like a lot in the grand scheme of things, but it did allow us to justify then putting more time and resource into expanding this program. And we've now moved from 6 buildings up to 25 buildings to try to scale up and improve our standard analytics processes that we tend to use. In parallel to the proprietary software that our controls provider could bring to the table, we also evaluated some other third-party software, in this case using the IES iScan product, which allowed us to undertake a broader range of data analytics associated with building performance. And so we could take HVAC BMS points. In these buildings, there was between 3,000 and 10,000 data points which we could access within our buildings, combine that with our energy data, our metering data, and combine that with improved occupancy and space utilization data, and try to find out where we were having some anomalies within our buildings. Typically, we identified about 30 typical performance anomalies that we were flagging up within our buildings, which we tend to come back to again and again. And it started to point us in the direction of where you might want to focus your attention if you were setting up some standard analytics to do continuous commissioning across these different properties.
Just 1 minute warning.
1 minute. Okay.
Thank you.
Nearly at the end here. So the final point I want to make is once we were gathering all of this data and doing this analytics, as part of that project, we were also completing building physics models across these pilot buildings. And we're starting to play around with how we might be able to then, one, use our data sets to calibrate the digital models so that we have some confidence that the models are telling us that are calibrated to reality, and then starting to do scenario modeling with those building physics models. And again, just touching on some of the points that David had made in his presentation, some of the more insightful analyses that we're able to do in here is to look at where things like occupancy assumptions would impact, your cooling strategies that you might want to take forward in some of these buildings. And what we found is very, very marginal changes in your assumption around occupancy, as an example, could have quite a profound impact on your perception of risk and how you might take forward cooling strategies or heating strategies within some of those buildings. So the value of those quote unquote digital twins starts to really come to the fore. The last couple of points I want to make, and I'll try to ram this into about 30 seconds, is to undertake the performance analytics, you need access to data. And one of our biggest challenges that we came across was data quality, right? So we've got a graphic on the screen, this little colorful red and green box, which is showing us all of the air handling units, which we have in one of our buildings along the left-hand side, and all the data points which we require to do our analytics across the top there. And anywhere where there's a green box, we have the data, and we can do something with that. And anywhere where there's a red box, we don't have the data for a whole host of reasons. So the key question is, why aren't we getting that data? And if we really want to ramp up our data analytics to help us and do the type of continuous commissioning that we want to be able to do in these buildings, we need to sort out where those data gaps exist. So some of the key challenges, data access barriers. Our 1-year plan, I think, has turned into about a 5-year plan. And a lot of that is around how we enable better access to data or get rid of some of those data gaps. Data silos, lots of systems have been developed in the past in silos with lack of attention to interoperability. And although I think we're emerging into this IoT world, I think we still have this danger of maybe developing a lot of these technologies in silos and not thinking closely enough about interoperability between systems. We have lots of issues around poor data structures. And again, when you have a historic estate, you're to a certain degree stuck with some of the historic assets that you have, where you may wish to draw data from. And some of those data systems have data architectures, which it's very difficult to go and do anything about. So a lot of work that's involved in going to understand this rich sea of data, which is largely inscrutable if it's not been designed in a way for open data access and analytics. Looking forward, I think some of the key areas of focus for us are going to be creating those golden sets of data, which we could then push out to a whole host of digital tools to help us improve our estate optimization, be expanding out geospatial mapping and looking at how we would integrate that, say, with other partners within the city, within the wider regions where our campuses are set. Scaling up data analytics, making that more efficient and making that more automated. Speeding up our data sets will help with that. And again, looking at how we can take those quote unquote digital twins, whether that's of buildings, energy networks, or hydraulic models or energy models, and looking at how we can use those to do scenario modeling to help us with our planning in the future. And I'll shut up there and gone past my time by a few minutes, I'm sure. So thank you very much for your time, and I'm happy to answer any questions or pick up with anyone that wants to speak about anything in detail.
Thank you so much, Dean. Genuinely appreciate that. Really exciting work that you're delivering. So always interesting to find out more. Just in the interest of time, moving quickly on to our third, last but not least speaker, Robin Peters from Snugg Energy. Robin founded Snugg in 2022 with a mission to make energy efficient homes simple and affordable for everyone. He's applying the experience he gained in setting up Aviva's digital business to the world of net zero. He has extensive experience across financial services, engineering and logistics sectors, and has lived and worked in 9 countries, so he has a real global outlook on the benefits that we can lever to the table. Robin, can I just pass over to you? Thank you.
Thanks very much, Fiona, and I'll try and recover at least a couple of minutes for questions. Danielle is going to show the slides, so I'm a little bit in your hands, Danielle. I think we're on the last slide there, so we probably need to go back to slide 1. There we go. You've seen them all in animation. Yeah. So thanks very much, everybody. Yeah, as I said, I learned. I'm basically trying to take what I learned at Aviva in where we made insurance buying much simpler by using intelligent use of data. So if you've ever bought home insurance online, you'll know that it takes 156 questions before you can get a quote for home insurance, and we managed to reduce that question set to 3 questions. By using access to various data sets that we had. The other element I'm trying to bring in is making it affordable. I mean, it's a very interesting link to the poll question, where most people reckon that cost is the biggest barrier to people adopting energy efficiency, which we certainly see as well. And my link to financial services, I think, can help bring that forward. So the next slide, I think, will be very familiar to everybody. So if you just move forward, Danielle. So two points here. First, the kind of the dark green pie on the left shows that 20% of total UK emissions come from homes. Basically, we're not going to hit net zero unless we fix homes, and that is a pretty difficult problem to do. On the right-hand chart is an extract from the Climate Change Commission forecasts on the capital expenditure needed to hit net zero. And again, the dark green slice in the middle of there shows the cumulative capital cost required, which is in excess of £250 billion, even using government estimates of what's going to be required. And that is enormous, and certainly not going to be delivered just by public sector financing. So hence the critical role of getting private sector finance involved in this. If we move to the next slide, then the barriers really summarise why insulation and home efficiency has been around as we mentioned earlier, as David mentioned earlier, for decades. Why hasn't it been adopted? Well, there are 4 key barriers we see. First is it is complex, certainly for consumers to understand. Even things like insulation have issues around condensation and thermal bridging, issues to deal with before you can you should really implement them. And we know that installation is highly disruptive. Very few of these changes happen without disruption to the household. Second, the market is fragmented. There's lots of people playing in this space, but very little effective join up between solution providers, financiers, grant providers, installers, etc., manufacturers. And we all know as well there's a chronic undersupply of installation capacity to the tune of in excess of 200,000 people in trade right now. It's expensive, so the government estimate is it costs £10,000 to retrofit a home. I think a lot of other estimates are that it's actually substantially higher than that. And government grants, while they're available, are limited, and probably rightly so, largely limited to the poorest householders, which means consumers have to bear the cost. And on the final point, it's an uncertain investment. Paybacks are long, uncertain, generally often in decades to get a payback on some of these investments. And people are rightly skeptical about some of the investments which are predicted to them. The industry has a bit of previous in terms of overestimating and benefits that might be available. So 4 big barriers which we're trying to overcome with Snugg, which is the next slide. And we have a slightly jargony thing. We call ourselves an ecosystem platform, but the less jargony bit is the bit on the right, which we're trying to make it simple for people to act. And by using a number of different data sources in the background, we try and help people along the journey to go from firstly understanding their home, so using data about their EPC is obviously the first point, to present to them what we know about their home and let them understand their specific own personal starting point, to help them develop a personalized improvement plan based on their budget, their attitude to carbon reduction, etc. To access financing, whether it's through grants or through additional mortgage lending, for instance. To get in touch with installers, again, difficult issue at the moment, but we can link them into the high quality kind of Trustmark approved installers to do the work. And probably our biggest USP, frankly, and I'll definitely be speaking to David about this, is on monitoring progress. So we need to create this feedback loop that once people do an initial investment, initial change, that they can see a tangible improvement through their smart meter or smart thermostat, etc., to give them confidence to make the next step. And a lot of the work we're doing on particularly the marketing element is nudging people to make that next step. So they may just do a plan and then drop it. We kind of give them the nudge to maybe get a quote and then get another quote. And then when they've done the first bit of work, maybe just raise the awareness of them that actually their neighbours may have done some similar work as well that they may want to look at. So that's the kind of overall journey. Just a quick diversion on this. One of the biggest challenges we've got at the moment is taking this from a highly personalised journey, and this needs to be individualised. Every individual is separate, but we're trying to move this to a community level. A lot of these implementations at scale need to be done at community level, And local authorities, for instance, are key stakeholders in actually making this happen. I think just for instance about things like district heating, where it only makes sense if you get a minimum number of people committing to it. We may be able to access discounts for installers if we work at community level, and obviously there's an eco element to this as well. So bringing this journey to community level is something that's quite important for us. A couple of quick slides afterwards, we talked about the cost element. So the next slide sort of brings to life a little bit the kind of nature of what we're trying to take people through. And essentially, we're trying to transform people's perception of the economics of home energy efficiency. So we call it going from a no-hoper to a no-brainer. And I mean, these are slightly illustrative numbers. But if you think on the left-hand chart of the no-hoper, where taking a government estimate of about £10,000 to upgrade a home, on previous fuel costs, you would have saved maybe £300 a year on fuel savings. And given that people generally spend about 10 years, maybe up to 12, 15 years in a home, over 10 years, you'd save £3,000 in fuel savings. So the obvious point would be, well, why should you invest in that if you are £7,000 down over 10 years? And what we're doing through the data sources and the analysis we can bring to bear in Snugg is changing that perception. So firstly, bringing people's awareness of better technology, new technology, more relevant technology to them, that they can get technology savings. Open up access to grants. So a lot of grant application processes are pretty opaque at the moment, and we're putting a lot of effort in trying to make this as frictionless as possible for national and particularly local grants. A key value dimension to this is that there's evidence emerging that improving the energy efficiency of your home increases the value of your house. And that needs to be taken into place when you're looking at the business case to make these investments, and we're doing some work around that at quite a granular level. Obviously, fuel savings have increased as fuel costs have gone up, but also there's an opportunity to benefit from feed-in tariffs, etc. There are better and more tailored benefits we can give by targeting more financial deals at people, going from the kind of one-size-fits-all, do something green and get £1,000 bonus kind of thing, to much more focused incentives around people's willingness to pay and the energy efficiency impact on their house. And the final point is looking at carbon credits. So if you install a heat pump, it's not guaranteed that you'll actually save fuel costs, given that you're exchanging relatively cheap gas for relatively expensive electricity. That's obviously an over summary, but what you do get by putting a heat pump in is a massive reduction in carbon usage, and that is a monetizable saving, which we can get money back to customers through our 400 carbon credit. So if you add all those things up, you end up with a far more compelling business case for a consumer to look at. The final chart then is this is why Danielle is doing it, is just a little look at kind of our UX, just trying to summarize it. So Danielle, if you go forward and just click play, it should work. All right, you can't hear the sound, but this is giving a little view of the UX we've got to help build the plan, come up with a business case that shows the cost benefit you get. Can
you try once more, Robin? Can you hear it now?
Yeah, give it a go. I don't think we're going to hear it, but give it a go.
Snugg provides a simple route to a personalised improvement plan. Using our simple UX, users can then tailor their plan to best suit their goals and budget. Efficiency improvements can seem expensive and have a long payback. We present benefits in a compelling way that includes all the benefits of investment, including house value impact and, in the future, carbon credits. We help people finance their improvements by pointing them to relevant grants and linking to appropriate savings or lending products. We help make it happen by partnering with selected installers who provide advice and quotes for any improvements needed. Decarbonising a home can be a long journey. Our personalised nudges encourage people to keep going and to track the benefits in their plan. Snugg can help banks achieve their goal to reduce financed emissions across their mortgage portfolio. We can identify which properties have most opportunity and then help the owners deliver the changes needed. We would love the opportunity to work with more banks on this exciting challenge.
So that's me, Dan. Apologies for the blatant plug, just like David, but I'm again happy to take questions, although I think we've got limited time left.
Excellent. Thank you so much, Robin. Really appreciate that. And always happy to have a plug when you're supporting us in that knowledge exchange. So never an apology required on that front. Just moving on to our final poll, which should appear on your screen anytime now. The question being, what type of funding and support are you interested in? The options being Green Heat Innovation Support Programme, 100% feasibility funding, Horizon Europe, Clean Energy Transition Partnership, or Energygit. If you'd just like to place your answers, we would really welcome your insight. Excellent. That's really informative. Thank you. That really helps make sure that we're guiding on the right track. So again, thank you for your input in that capacity. We are running slightly over, so my apologies to everyone that's online today. We are going to just have a little bit of a question and answer session for anyone that is able to retain their attention on the call. And I believe we have a question to ask, Danielle's one that's come in. Yep, this one is for David. David, if you just could I just ask the panel to come back online with their cameras and unmute themselves, that would be great, thank you. This question is for David. Are the planning rules consistent across Great Britain regarding heat pump installations? And if not, is there a need to standardise them?
Probably not the best place to answer this. Maybe Robin's got a bit more insight. We see.
Open it up to the panel.
Yeah, I think so.
Any response to Robin?
I've got limited comment to make, other than one interesting thing. I don't know whether anyone's heard of Chris Stark, who's the chief executive of the Climate Change Committee, made an interesting comment recently on the planning regulations regarding heat pumps, which his view, and I've listened to him, is they're probably too stringent, because you can put a gas boiler in with virtually no planning control, but a heat pump is highly regulated, which is one of the main barriers. And there's it will be less efficient, but if you can afford additional electricity to make it run, to afford a bigger pump, it might be justified. So I'm not sure that's the exact answer, but I think there's definitely a push for relaxing some of the planning constraints.
At the end of the day, we all have to get a SAP score for a new build, so it's the same across the country. With the variation we've seen is came in restrictions on things like air source heat pumps due to noise when you're densely packed, and therefore then prioritising, say, panel heaters in a small densely packed estates, because there wasn't, it was too expensive to put in ground source. No one wanted exhaust there, and the air source was going to be too noisy. But there are ever more technological innovations there to reduce the noise in the air source heat pumps, but it just comes at a cost.
Excellent, excellent. That's great, thank you. Well, I think in the interest of time, and we are just slightly over, we do have other questions to respond to, but we'll follow up after today's event just to make sure that all attendees have a sense of a response from the expert panel. So massive thank you from me to you as the audience for taking the time to join us today, and for all the questions that you have forwarded on to us. We really do hope that you found today's session useful. There have been a lot submitted, but unfortunately we just are out of time and we haven't been able to answer them. That being said, we will follow up through follow-on communications after today's event. Your feedback, as I noted at the beginning of today's webinar, is used to plan future events and initiatives, particularly within the HeatSource activity realm. So please do also complete the feedback form that you'll receive after this event. And finally, please see links in the chat function for related sites to stay up to date with the latest state of the art and registrations on the newsletters. You can contact each of the organisations through these links for further information or references if required, and follow us on LinkedIn, Twitter and Facebook. And that just leaves me to say thanks for attending. Apologies that we did run slightly over, but I think it was well worth it in terms of content today, and we look forward to welcoming you at our next event. Bye for now. Thanks everyone.
Thanks. Bye.